Our final speaker this morning is Shingo Kajimura. This year, Shingo was one of just 102 recipients honored by President Barack Obama at the White House with the Presidential Early Career Award for Scientists and Engineers. This is the highest honor bestowed by the United States government on science and engineering professionals in the early stages of their independent research careers. Shingo's work focuses on understanding obesity and on finding new methods to combat the metabolic problems that result from it. The title of his talk today is Engineering Fat Cell Fate to Fight Obesity. Shingo.
Thank you. First of all, thanks for coming. And you raised the bar really high. So, and then it's my great pleasure being here today. So I'd like to tell you about fat and metabolism and obesity before you go into lunch. So as you all know, obesity is one of the most serious health concerns in the United States and also in the world. Obesity is really a main risk factor for a number of metabolic diseases, such as type 2 diabetes, cardiovascular diseases, hypertension, and certain types of cancer. So let me briefly tell you about my background. I was born and grown up near Tokyo, Japan, and then I moved to the United States about 15 years ago. So my diet obviously became sort of westernized, which I really like, and then I gained 20 pounds. So I put myself on diet and eventually lost weight. But as soon as I stopped doing it, I regained weight. So the question is, why is it so difficult to maintain our body weight? So body weight is maintained by energy balance between energy intake and energy expenditure. So energy intake, as you see here, exclusively comes from food intake, right? Meaning that how many pieces of bacon you had this morning really counts. And the energy expenditure largely consists of three elements: cellular function, exercise, and thermoregulation. This thermoregulation is the energy that we spend to maintain our body temperature. So we normally don't realize this, but all the animals, mammals, including humans, spend tremendous amounts of energy to maintain our body temperature, particularly when we face a cold environment, like summer in San Francisco, and particularly near the Parnassus campus where I am now. So so when you face cold environment, exposed to cold, we mainly use two strategies. First is to use muscle. We shiver muscle to generate heat. It's called shivering thermogenesis. But the second way is to use this very specialized energy-burning fat. It's called brown fat. So brown fat is a fat, adipose tissue, but functions completely opposite from white fat. So white fat is the one that I have lots in here, which mainly stores excess energy. On the other hand, brown fat dissipates, uses energy, and produces heat. It's called non-shivering thermogenesis. So this is particularly important for babies who don't have enough muscle to shiver, or for small animals or hibernating animals like bears that need to maintain their body temperature during the hibernation without muscle shivering. So this, in humans, it's been thought for many, many years that only babies have it and we don't. But now, recent studies clearly show that actually adult humans, we do have significant amounts of brown fat. It is estimated that we have about 50 to 60 grams of brown fat on average. And this can consume energy somewhere close to 4 kilograms or about 10 pounds of white fat per year. So this number is very significant, right? So what we like to do in our lab is to understand the fundamental biology of brown fat. More specifically, we like to understand the molecular circuits or pathways that regulate brown fat development. And eventually, we like to reactivate or reconstitute these pathways in adult humans. So therefore, this could increase energy expenditure and hopefully counteract obesity and obesity-related diseases such as type 2 diabetes. So the simple description in my lab is engineering fat cell fate. What I mean by this is that we try to convert some of the white fat into energy-burning brown fat, and this will into counteract obesity. We think this approach is sort of unique and novel in a way that so far, all the anti-obesity drugs that are approved by the FDA are to depress energy intake, either by depressing appetite or inhibiting lipid absorption by the gut. But there's no drug so far which is able to increase energy expenditure at this moment. So if we can activate brown fat, or if we can increase the amount of brown fat, we think that this will provide alternative approach to modulate this energy expenditure or energy balance, and presumably functions synergistically together with these conventional anti-obesity therapies. So one of the approaches we're taking is to understand the molecular changes within fat in response to cold. As you may know, cold adaptation is actually one of the most efficient way to consume or burn energy, sometimes more than exercise. And so it's a great way to consume extra calories, but problem is it's not comfortable, first of all. And it's not for everyone, particularly if you have cardiovascular risk. It's not good for heart. So what we like to do is to reconstitute, reactivate this cold response only in fat, but other organs like brain are completely intact. So we think we call it fat selective cold mimics. Okay. So some of you may think that if you lose weight, if you want to lose weight, you just simply eat less and exercise more, right? That's true. But it's not entirely true. For example, many people actually gain weight when we age, right? Although you eat the same amounts of food. It's called age-related obesity. And it's not because you become lazy or anything. It's simply your energy expenditure goes down. Okay. And also, there are many people who just simply cannot exercise enough because of their physical disabilities and other reasons. And in the near future, probably a lot of people are going to space. And one of the major difficulties for astronauts is that they have to exercise lots to maintain their muscle mass and maintain their energy expenditure. So the whole point I want to make is that we do need alternative ways to modulate this energy balance, except restricting food intake or exercise. So I hope I can convince you that brown fat research is important, not only for basic science and for hibernating animals, but also it can have a major impact on the future therapeutic interventions for anti-obesity therapies. Thank you very much.